Hello everyone. Today we're going to be looking at a topic called solving systems of equations. First of all, what these are, a system is just two equations, which in our case are going to be lines. So we have line 1 equation, and then we have line 2 equation. Now, because they're lines, what we can do, or what happens is, if we were to put these lines on a graph, line 1 might look like this, line 2 might look like that, and then what we can find is the location where those two lines cross. That is the coordinates of that spot there, whatever x that is, whatever y that is. All right, and this will be the solution to the system of linear equations. Sounds pretty fancy, eh? That's how it is though. Now, we can do it with graphing, create the picture, which we did last day. But what I'm going to do is I'm going to show you a way where we can do it algebraically. And the benefit of that is that the answers can be more precise than with a graph. Elimination. That's the name of this process. The trick is when you add or subtract something from both sides of the equation stays the same. And by doing that, we can eliminate variables and get closer and eventually to the answer. Here's an example that'll help you out. Suppose you have one line written in general form that looks like this. 5x plus 7y is equal to 19. And let's say there's a different line that looks like this, also in general form. Okay, so we can graph these. You know how to do that. Find the x-intercept, find the y-intercept, connect the dots. What we're going to do is algebraically. And so how this works is, first of all, you have to write the equation so that the x's line up with x's, y's with y's, and the lone number on the other side. Equals with equals too. And what we're going to do is we're going to add and subtract these equations from one another in order to eliminate one of the variables, either x or y. Now, what I see here is that we have a plus 7 and a minus 7. Well, if you have a plus 7 and you add a minus 7 to it, you're going to get 0. That is, these will be eliminated. If you have 7y plus negative 7y, you get 0y, which is just 0. The y has been eliminated. Okay, so we look for coefficients that are opposite from one another. And in this case, it's the y, so that's what we're going to eliminate. So what we do, once we set up the equations looking good, one on top of another like this, in this situation, we're going to add them together. So, we do the work now. 5x plus 2x, 7x, plus 7y, subtract 7y, that's gone. Just zeros we showed over here. And on the right hand side, we got 19, subtract 12, which is 7. So that creates 7x is equal to 7. That creates 7 is x is equal to 1. So remember, what we're trying to do is find out where these two lines cross. And to do that, we need an x value and a y value. We got the x value. So, what's the y value that matches along with it? Well, what you do is you take this x and you just substitute it into one of these two equations, the easier one. to make your life simple. And then you just solve for the y, because that will be the one variable that's missing. So I'm going to choose the first one just because. N equals 19. From our good work over here, we know that x is equal to 1. So there it is. Y remains a mystery. So we work this out. This is 5 plus 7y is equal to 19. 7y, that goes over, is equal to 14. And so therefore, y is equal to 2. Well, putting these two values together creates the final answer. And the final answer is that the solution to the system is the location x